the previous video, I showed a program for a typical stream gauging application which measures a water level SDI-12 radar sensor every 15 minutes and stores data every 15 minutes. This 15-minute data interval is typical. But what if I'm on site doing maintenance or troubleshooting and I don't want to wait 15 minutes for the next set of measurements to be made? In this video, I'm going to add some lines of code to my program that will allow me to trigger real-time measurements and view them in the public table while I'm doing a site visit. This is a great tool for troubleshooting and verifying that sensors are working correctly in the field. To do this, I will open my stage example program in the CRBasic editor and add a new variable to the variables section. I will call this variable real-time. This is the variable I will use to trigger real-time measurements. Since I'm going to use this real-time variable to trigger measurements in the field, I want to make sure it is easy to find in the public table. I can do this by adding dividers in the public table that will separate user variables from measurement variables. I will do this by creating another public variable called user options. This time I'm going to set the variable to type string, and I'm going to assign it some characters that will show up as a divider in the public table. In this case, the divider will be a row of equal signs. I'll enter them here. And since this is a string variable, I need to enclose the string of equal signs in quotation marks. Next, I will place my cursor just above the measurement variables and create another variable named measurements. And just like I did with the user options variable, I'm going to define it as type string, and I will set it to some equal signs enclosed with quotes. These two variables are not going to be used by the program to hold the results of a measurement or a calculation. They're simply going to be displayed as dividers in the public table. I'll demonstrate how the dividers look later. For now, I've got the real-time variable and I want to configure it to trigger some real-time measurements. I begin by scrolling down to the bottom of my program and creating some space after the next scan instruction. Now I will add a slow sequence to the program. A slow sequence is like the main scan in that it's a loop that executes the instructions and code within it. The main difference between a slow sequence and the main scan is the slow sequence operates at a lower priority than the main scan. This means the instructions or code in the slow sequence will not interfere with the instructions in the main scan. Since this is a stream gauging station, I want the 15-minute water level measurements to take priority over the real-time measurements that are just used for viewing convenience during a site visit. So, the 15-minute measurements will stay in the main scan, and I will create a slow sequence for the real-time measurements. To add the slow sequence, I will find slow sequence in the list of instructions and insert it here. Then I'm going to add some blank lines and close off the sequence with the end sequence instruction. Inside the slow sequence, I will create a do loop by inserting a do instruction. Then I will add some blank lines and close off the loop with a loop instruction. The do loop is a section of code that operates in perpetuity or until an exit condition is met. I'll come back to that in a moment. Next, I'll copy the measurements from my main scan and paste them into the do loop where the real-time measurements are made. I will press Ctrl-I to rebuild the indentations. Notice I did not copy the call table because I don't want to store these real-time measurements. I will only view them when I'm in the field. Now I have a slow sequence that has a do loop in it, and within that do loop, I've got a duplicate set of measurement instructions. If I send this program to the data logger as it is now, the data logger will execute the code in this do loop as fast as its processor will allow without ever exiting the loop. So what I need to do is add a time constraint to this. I could use a scan instruction inside the slow sequence like I've done in the main scan. But the problem with that is the sensor response time might be longer than what I've set as a scan interval for the real-time data, which would cause skipped slow scans. So instead of using scan, I will use the delay instruction. In this case, I'm going to set the delay to 5 seconds. This limits the do loop to only execute as fast as every 5 seconds. If I have an SDI-12 sensor that takes longer than 5 seconds to respond, that's okay, because when I'm viewing real-time data sets in the field, I'm not recording measurements. I just want to verify that sensors are working correctly. The next thing I need to do is configure the real-time measurements to only occur when I tell them to. I will create a conditional statement after the delay instruction that says if real time is greater than 0, then make these measurements. So I type if and press F10 here to bring up my list of variables and select real time and type greater than 0. Then I will type endif below SDI12 recorder to complete this conditional statement. Now I have my slow sequence with the do loop, a conditional statement with my measurements in it that only executes when this real-time variable is greater than 0, and the fastest that everything can run is every 5 seconds. The last thing I want to add is a safeguard in case I enable the real-time measurements and then forget about it and walk away and end up draining the battery dead. To prevent this from happening, I'm going to press F10 and select the real-time value again, and I'm going to say real-time minus equals 5. This minus equals is a compound subtraction. So really what this code says is every time this conditional statement executes, subtract 5 from the value called real-time. What this does is create a timeout that will prevent me from getting myself into trouble if I walk away and forget I've enabled the real-time measurements. For example, if I set real-time to 300, this timeout will start at 300 and count down by 5 until real-time is 0 again. Now when I go up here to the top and hit the compile button, the program compiles OK, but I do have 2 warnings. These warnings are okay. The program will still run fine. The warnings are there because I declared the user options and measurements variables at the top of the program and then never used them in the main scan or slow sequence. That's fine because I only added those variables to use as dividers when I view the public table. I don't need them anywhere else in the program, so I'll click OK. Now I will send that program to the logger and view the measurements in the public table. Click the Compile, Save, and Send icon to send the program to the data logger. I can do this because I've already connected to the CR300 attached to this computer and I don't have any data on the data logger I need to save. It takes a moment for a program to be sent and compile on the data logger. I may hear the data logger disconnect and then reconnect over USB from the computer. When it's complete, I get confirmation that the program compiled. There it is. Compiled OK. So I will click OK and minimize the CRBasic editor window. I'll select the Monitor Data tab in the PC400 window. When I look at the public table, I don't see the new variables I created. What I need to do first is update the public table for the modified program. The easiest thing to do is to delete the old public table and add it again. Click on the record number field, hold Shift, and click on the last entry to select everything. Now click Delete. Click the Add button and drag the public table into the first cell. I can see 3 new variables that I created. The user options and measurements variables are just being used as dividers for my table. Under user options, I have the values I interact with and can change to affect the behavior of the program. Down in the bottom section, I have my measurements from the data logger based on the sensors I programmed it to measure. As expected, nothing is updating right now because the data logger has not hit the 15-minute interval I set in the program. If I waited until the top of a 15-minute interval, I would see everything update, but I don't want to wait that long. To view the real-time data, I need to set the real-time variable to a value above 0. I'll set it to 20, in this case for 20 seconds, then press Enter. Notice that the real-time value is counting down by 5 each scan. Now I will see these values update. Panel temperature and battery are updated first. Then a few seconds later, once my SDI12 sensor responds, stage, distance, sensor voltage, and the error code fields appear as well. These are updating every 5 seconds because that's the delay time I set in the do loop of the running program. This is the timeout feature I added to the program, and the real-time measurements will stop once real-time returns to 0. In a second or two, the values will stop updating. If I want them to continue longer, I can add more time to the real-time parameter to see those values update again. The 15-minute interval data will continue to be stored to final storage regardless of how often I view the real-time data. In this demonstration, the stage measurements have all been successful. But if for some reason a NAN is returned instead of a valid measurement, I can use the data logger terminal emulator to communicate directly with the SDI12 sensor to help diagnose the problem. The Campbell scientific video, SDI12 Sensor Transparent Mode, demonstrates how to use the terminal emulator to verify communications, change an SDI12 sensor address, and send commands directly to the sensor and perform troubleshooting. This video is available on the Campbell Scientific website or on our YouTube channel. In the next video, I will demonstrate how to add a subroutine to make my program easier to read.